Okay, so here we have a function for a quadratic. We're given the equation, and we're trying to find as much as we can about this graph given the equation. Okay. Now, obviously, we can make a table right away and figure out, pick some x values, get some y values, and then graph it from the table. But we want to know certain characteristics, and certain problems might ask, instead of graphing the whole thing, it's good to be able to just find the x-intercept, or just find the vertex, or just find the y-intercept. So being able to get as much information from an equation as you can is important. Okay, so we're given this function f of x equals 2x squared plus 4x minus 3. The first thing I like to do is identify a, b, and c, because standard form quadratic is ax squared plus bx plus c. So a is always in front of x squared. So a in this problem is 2. Okay. B is always in front of x, so b is 4. And then c is always the constant, in this case negative 3. Okay. And there's a couple things we could say about the graph without doing any work. First of all, the opening. Okay. Does this parabola open up or does it open down? This all depends on the a value. If a is positive, it opens up. If a is negative, it opens down. In our case, a is 2. Okay. So our graph is going to open up. Okay. Because a is greater, or a is positive. A is greater than 0. Okay. All right, the y-intercept. We could also find the y-intercept without doing any work. The y-intercept is always the c value. Okay, because again, if you think about it graphically, or the y-intercept is when x is 0, and if x is 0, then the a term goes away, the b term goes away, and you're left with just c. So the y-intercept is negative 3. Okay, so without any work, we know 2 important facts about our graph. All right, the axis of symmetry. Axis of symmetry has a formula. It's x equals negative b over 2a. Okay. Well, since we know a, b, and c, and we only need a and b, we could plug this into the formula. All right, our b value is 4, so the opposite of that would be negative 4. Divided by 2 times a, and a is 2, so 2 times 2. Okay. Simplify, and you got negative 4 over 4, which is negative 1. Okay. So your axis of symmetry is x equals negative 1. Okay. All right, the vertex. The vertex is a very important part of a quadratic function. If we know the axis of symmetry, which we do, we automatically know the x value of the vertex. Okay. The axis of symmetry is always the x value of the vertex. Okay. So since the axis of symmetry is negative 1, we know the x value is negative 1. We don't know the y value of the vertex. We have to find that. To find the y value of the vertex, if you're given an x value and you need a y value, you just plug that x value in. So we're going to plug in negative 1 into the function. Okay. So we're going to find f of negative 1, and that's going to give us the y value of the vertex. Okay. So we're going to plug that in. 2 times negative 1 squared plus 4 times negative 1 minus 3. Okay. Wherever you see x in the original function, we plug in negative 1. All right, you simplify that, and you get 2 minus 4 minus 3, that's negative 5. Okay. So our y value is negative 5. Okay. All right, and then everything else, we have all the information we need now. Okay. Since the parabola opens up, that means the vertex is going to be the lowest point on the graph. It's going to be the minimum. Okay. So this graph is going to have a minimum value at negative 5. So negative 5 is going to be the lowest point on this graph, the lowest y value on this graph. Okay. And the negative 5 is from the y value of the vertex, and the vertex has to be the lowest point. Okay. Domain and range. Domain of every quadratic is going to be all real numbers. So you could write it, fancy R. That's a bad one. You could do fancy R, or if you want to write it as an interval, it'd be from negative infinity to infinity. Okay. The range, since, we already said we have a minimum at -5. That means every y value is going to be bigger than -5. So we could write that as an inequality. Okay, if every y value is bigger than -5, that means that y is greater than or equal to -5. If you want to write that as an interval, okay, it means -5 is the lowest value, and it's included in the graph because it is the vertex. It's part of the vertex. So bracket, and it goes all the way up to infinity, parenthesis. All right, so we have a lot of information here, and we could start to assemble our graph. Okay. I'm going to start with the axis of symmetry. You don't have to draw the axis of symmetry. It's not really part of the graph. Okay. But visually, it's nice to see. Okay. So I'm going to put a dotted vertical line at -1. Okay. X equals -1. All right, then I'm going to graph my vertex. My vertex is -1, -5. So it's going to be on the axis of symmetry, of course. So -1, -5. So down here, just enough space. Okay, and then I know another point too. I know the y-intercept. The y-intercept was -3. Okay, whoops. So I'm going to graph -3 on the y-axis. That's right here. All right, now the cool thing about the axis of symmetry, if you know a point to the right or the left of the axis of symmetry, you automatically know its reflection over the axis of symmetry. Okay, so since we have the y-intercept, and it's 1 to the right of the axis of symmetry, we could go 1 to the left of the axis of symmetry and put another dot. Okay, so 3 points, you need the vertex and 2 other points to kind of make a good quadratic graph. I'm going to get 1 more point. I like graphing these with 5 points. So to get another point, you just pick an x value. Okay, we know what happens when x is -2. We know what happens when x is -1. We know what happens when x is 0. So we just pick another x value. Let's find, I'll plug in 1. Okay. So I'm going to find f of 1 and see what comes out. Okay. So that's going to be 2 times 1 squared plus 4 times 1 minus 3. Okay. So that's going to be 2 plus 4 is 6 minus 3 is 3. Okay. So f of 1 equals 3, which corresponds to the ordered pair 1, 3. So I can graph that point. 1, 3. It's up here. Okay. Now again, since I know a point to the right, I could reflect it over to the left. So since I know 1, 3 is a point, that means over here at -3, 3, that's also going to be a point. Okay. So now I could go ahead and connect my dots in a, I'll try my best to get a good U-shaped parabola here. Okay. All right, not perfect, but good enough. All right, and that's, that's a lot of information. We got a lot of information from just knowing the equation.